State and prove that any version of the central limit theorem statement, let x1, x2 and so on xn denote the observations of a random sample from a distribution that has mean mu and variance sigma square, then the random variable yn is equal to sigma I varying from 1 to n xi minus mu upon sigma square n is equal to square root of n bracket starts xn bar minus mu bracket close upon sigma has a limiting distribution that is normal with mean 0 and variance 1. Now proof. Let us assume that moment generating function mt is equal to e into e small e raised to power t x exists for minus h is less than t is less than h. Here yn is equal to sigma I varying from 1 to n xi minus n mu upon sigma n, which is equal to x1 plus x2 and so on xn minus n mu upon sigma square root n is equal to x1 minus mu plus x2 minus mu so on plus xn minus mu upon sigma square root n is equal to x1 minus mu plus x2 minus mu so on xn minus mu upon sigma square root n. Therefore, moment generating function of yn is equal to my and t is equal to e small e raised to power t yn is equal to e small e raised to power t x1 minus mu plus t into x2 minus mu so on plus t into xn minus mu upon square root of n is equal to e pi varying from 1 to n e raised to power t xi minus mu upon sigma square root n. Since xi is a independent is equal to e into small e raised to power t xi minus mu upon sigma square root n bracket close square bracket close whole raised to power n is equal to e 1 plus t xi minus mu upon sigma square root n plus t square upon 2 xi minus mu square upon sigma square n plus o t square upon n raised to power n p n raised to power p bracket close square bracket close whole raised to power n is greater than 2 is equal to 1 plus 0 plus t square upon 2n plus o into t square upon n raised to power p bracket close square bracket close whole raised to power n. P is greater than 1 since e is xi minus mu is equal to e xi minus e mu is equal to mu minus mu is equal to 0 and e xi minus mu whole square is equal to sigma square. Let n tends to infinity, therefore limit n tends to infinity mt n is equal to e t square upon 2 for all values of t. Therefore the theorem variable yn has the limiting distribution with mean 0 and variance 1.